Hey, this is Patrick Ryan and Team 22. Today we will be discussing our progress report presentation. We intend to show how as a team we have made progress in further narrowing our scope into a more specific area. The mission of our project is to compare data, results, and the economic feasibility from our own experiments to previous simulations or experiments, to compare different EOR methods, and to also determine the best and most economic EOR method for the Gulf of Mexico just 90 miles south of Baton Rouge. Our team includes 5 members: Logan Procell, who was elected our project manager and to help each member stay on task, while also being in charge of our weekly goals and schedule and to overlook any experiments we conduct. Andrew Broom will take responsibility with contacting the industry professionals and serve as a liaison between them and our team. Part of this role is to attempt to gain access for our group and to a well site which is using EOR if possible. Andrew Forster will serve as our primary contact between professors such as Dandino Rao if he is willing to aid us and our team. Andrew Forster will also work to interpret any data or research attained this way and to find the ways in which it pertains to our experiment. With the aid of these professionals and the data they could potentially provide, we hope to be educated enough on these processes to make an educated decision about the wells in our own area in the Gulf of Mexico. Mitchell Rubion and Patrick Ryan will serve primarily as the members who will gather the research materials pertaining to our project and the organization of these materials into a collective binder or Google Docs spreadsheet, as well as determine an educated estimate of the budget needed to complete any travel or building material expenses. We as a team will all aid in attaining a consistent scheduling system while also utilizing any research, experimentation, or data attained from industry professionals or professors.
Scheduling activities is a very fundamental and crucial step in order to finish any deliverable. Having a well-thought-out, step-by-step plan can make any project exponentially easier and less stressful. With that being said, in addition to finishing the final presentation, project management plan, and meeting minutes by December 9th, our team will have smaller personal deadlines to meet, including talking to Dr. Dandino Rao by October 28th, meeting with industry professionals, and possibly visiting a rig site to see physical evidence of some of the EOR methods we are researching by no later than November 13th, planning out and having an understanding of what small-scale experiments we will have to get done for the next semester by November 20th, and at least one meeting a week with the team to discuss the personal goals we have met and what research we have attained, and documenting those meetings in order to make sure all members of the team are on the same page. Also, we will set up a Google Drive that will allow us to share what research we have found and make it easily accessible for all members. In addition to a digital copy, we will keep hard copies of all research we find via Kinko's and keep it stored safely as a backup. As we progress throughout the semester, we will make sure to adapt to whatever curveball may be thrown our way. We understand that schedules do not always go according to plan. However, by meeting every week and holding every member of the team responsible, we are confident that we will be able to meet these deadlines with relative ease.
In order to gain a more extensive understanding of enhanced oil recovery methods, issues, uses, and implementations, our team plans to meet with at least one member of the LSU Petroleum Engineering faculty, at least one current oil industry professional, and to visit a rig utilizing an enhanced oil recovery technique. First, we are planning to meet with Dr. Dandino Rao of LSU's Petroleum Engineering Department by October 28th. Dr. Rao is currently our Petty 4051 Reservoir Management Professor and inventor of the gravity-assisted gas drainage EOR technique. Due to his extensive record, we believe Dr. Rao will be a valuable asset to our project, assuming that we can gain access to his abundance of information, resources, and experience. Also, we hope that Dr. Rao will be able to provide us with a reference to another professor or associate with knowledge of this topic. Second, we are hoping for the opportunity to meet with Mr. Stephen M. Pamilia, P.E., Vice President of the Waldemar S. Nelson & Company consulting firm, by November 13th. We have chosen to meet with Mr. Pamilia due to his extensive experience and expertise in the oil industry. We also understand that Mr. Pamilia is a very busy and important man who may not be able to afford us the time due to his schedule. Last, our team aspires to find a local oil company exercising EOR methods through either the recommendation of an associate or through the data available on either Access or Sunrise. Our plan is to make a trip to this rig and to capture some of the photos of equipment in use and to find cost estimates of said equipment and the estimated cost of utilizing an alternate method.
Many large-scale pilot tests for various EORI methods are beyond the scope of our project. Accurate pressures and temperatures are required to demonstrate the reservoir conditions and how the enhanced recovery methods work. But we do have the capacity to gather materials and perform simplified laboratory experiments that demonstrate the overlying EOR processes. One of these experiments we are planning to design incorporates the reservoir sweeping power of immiscible gases injected into the reservoir. For this experiment, we wish to displace oil from some kind of porous media using an injected gas. We need to plan the physical design of the experiment as well as any metrics that we need to measure. In the same vein, we are planning to design an experiment that utilizes steam to drive hydrocarbons to production. This experiment would parallel the larger fire flooding EOR procedure. Again, we will need to design the physical setup of the experiment as well as any measurements that should be taken. Other experiments we plan on making will demonstrate problems that many EOR methods have. A large issue that impedes sweep efficiency is anisotropic permeability in the reservoir. Reservoirs tend not to be homogeneous in permeability, which leads to the relative density of the injected fluid to dictate the invasion front into the formation. These experiments are going to be designed to demonstrate concepts more so than to serve as guides for how to handle the EOR injection. The budget for our experiments is going to be kept relatively small, so the scale will also be kept small. The equipment necessary to recreate our experiments can be readily bought at any Walmart or hardware store. We plan on finalizing our experiment designs by November 20th, and this should allow ample time to incorporate the designs into our project management plan.
Enhanced recovery in the Gulf of Mexico. Our original research plan was to investigate many methods of enhanced oil recovery in depth. However, after this initial research, we realized that we would not have enough time and resources to include that many recovery methods in our study. Furthermore, we have decided to narrow our scope of work and focus our research on Dr. Rao's tertiary method of gravity-assisted gas drainage, in addition to examining hybrid methods that would yield the highest economic efficiency for the reservoir types relevant to the Louisiana area. We plan to examine the advantages and disadvantages of the different enhanced oil recovery methods and use our findings as evidence for proving gravity-assisted gas drainage as the most efficient method. We want to include specific data on how much these methods compare in cost of setup and performance, as well as recovery percentage and efficiency. We also plan to examine the environmental risks and benefits to further the strength of our case. We also have access to a gas injection simulator provided by LSU's Petroleum Science and Technology team, and we plan to include those results. We also have noted that our research scope is subject to change in order to adapt to our findings and our general increasing of knowledge on the subject. We expect to have a more clear idea of the extent of our project after we consult Dr. Rao and other resources. Furthermore, due to the unpredictable nature of research scope, we have set a general deadline to have gathered all necessary data and research by November 20th.